Okay, questions from homework that you guys came across? Yeah. 35. Is that a word problem or just okay, page 226, number 35. Here we go. Okay, height of a ball. The ball thrown directly upward from a height of 6 feet with an initial velocity of 20 feet per second. The function s at t was equal to negative 16t squared plus 20t plus 6 gives the height of the ball in t seconds after which it has been thrown. Determine the time at which the ball reaches its maximum height and also find the maximum height. Okay? So you understand you're tossing a ball, that is doing this. Okay? So you're tossing a ball that's doing this. The distance here is it's 6 feet up. Okay, top of your arm when you release this ball upward was 6 feet off the ground. And then here's the ground level right here. So technically, if I were to have the XY axis drawn right here, this is what this parabola would look like. This portion of the parabola here doesn't really exist for you because that's your initial height. Your portion of your parabola going this way also doesn't exist because it's underground. So you made a big hole in the ground if that's the case. All right, so they tell us that the equation that we're going to use is s at t is equal to negative 16t squared plus 20t plus 6. Do you agree this should be an upside down parabola? Yes, our t squared term is negative. It's upside down parabola. Okay? That means that our vertex will be our maximum. Okay? So I talked to you guys yesterday about finding the vertex of a parabola. What equation? What's the simple first equation we use? Negative what? Negative b over 2a. So I have negative b over 2a, and then plug in, right? Okay, so negative b, I have negative 20 over 2 times negative 16. So that's, I've got to plug it in a second. So I get negative 20 over negative 32. So that's going to be positive. So that's going to be positive. Let's see, 4 goes into both, right? So I get 5 over 8. So at 5/8 of a second after you release this ball, it is now at its maximum height. At 5/8 of a second after you release this ball, it gets to its maximum height. Okay? So that's the x component of the vertex. So at 5/8 of a second, we're at that height. So let's plug it into our original equation. So I have negative 16 times 5/8. That's going to be squared plus 20 times 5/8 plus 6. Okay? So at 5/8 of a second, it's going to reach its maximum height. When I do this equation, that's actually going to tell me how high the ball actually had gone. So doing the arithmetic, and I'll need you guys to help me out with the calculator. That's going to be 25 over 64. The reason it's 25 over 64 is 5 times 5 is 25, 8 times 8. I can go ahead and do this one. I guess I could reduce it. Let's see, 4 goes in there twice, 4 goes in there 5 times. That's going to give me 25 over 2 plus 6. 8 goes in there twice, 8 goes in there 8 times, 2 goes in there, that's over 4. So I'm going to get negative 25 over 4 plus 25 over 2 plus 6. So let's do the arithmetic. Does anyone have a calculator to do this? So negative 25 divided by 4, enter, plus 25 divided by 2, enter, plus 6. What is it? 12.25 or 12 and a fourth? Okay, so 5/8 of a second after you release this ball into the air, it's going to reach a maximum height of 12 and a fourth feet. That's how you do that problem. Other questions you might have come across? Yeah?
Just in general, have you found the minimum
Okay? That's a good question. So, that's basically the two types of parabolas we'll deal with. They might be fatter or skinnier, shift left, right, up, and down, right? So this portion right here is a minimum value. And you're going to use the equation negative b over 2a and then plug in. Okay, and that's going to find us the vertex. The vertex, the x component, is going to be when will this reach our minimum value? Our y component is how minimum are we going to go. Same thing here. This is going to be a maximum. This is going to be the vertex. And you still use the exact same equation in order to do it. In order for your equations to be set up appropriately to use the negative b over 2a, you have to have it as ax squared plus bx plus c. So if your equation is set up in standard form, which looks like this, that's going to work for you to find the vertex. Okay? Do what's that? Today we're going to hit on when that equation doesn't look like that, which usually means we've completed the square off of that, and that puts it into vertex form. Okay? Yeah. Yeah. Absolutely. Whoa. I'm going to have to work on this. I got to work on that for you. I'll figure it out. Yeah. All right. If you have your homework complete, go ahead and pass it on in. If you have any old homework, you're passing in too. Okay, Zach. This is the only time you put that grab out of it. Alex is not here. Sarah McGuire, are you here? No. Sarah McGuire's not here. Alex is not here. Alex is not here. Brad is here. Mike is back. Mike is here. And Mike is here. Yep. All right. So I'll put these in a safe spot. These guys come back and remind me it's in this round cabinet over here. All right. So today we are going to be converting these into vertex form. We're going to convert these into vertex form. Vertex form is just completing the square. I'm not really going to go completely off the notes. What we'll be doing is going to these worksheets. Okay, ready? Set. Okay, let's say we have y equals 2x squared plus 8x minus 7. Okay? This is going to tell us an awful lot. This, as it's set up right now, will tell us that our y-intercept is at the point 0, negative 7, as far as our graph goes. Is that necessarily an important point? It is a point, but is it important? I mean, is it showing you like the minimum or the maximum value of the graph or anything? Okay? So that's about all that standard form is going to get us. If we modify this to put it in vertex form, that's going to help us out a lot. Now, vertex form is completing the square, and usually when you complete the square to solve, it's equal to 0. Okay? But this isn't equal to 0. So you guys with me? All right. So leaving it as y equals. What was the first step in completing the square if it was equal to 0? Add 7. Okay? I'm not going to add 7 on this one. What I'm going to do is I am going to just make a space. So I'm going to try and keep everything over on the right side. So I'm just going to do this. I'm going to make a space. So step 1, make space. Seem okay so far? Can you all see that there's been space made between our linear term and our constant? Linear term being x and constant being the number that doesn't have a letter. Next step. Be sure x squared, or 1x squared, is your lead coefficient. Okay, what's my x squared term right now? 2. So I want it to be a 1. So what do I have to divide everything by in order to make my x squared term be 1x squared? What's that? 2. Perfect. So now I got to do this. So now look at this. That's going to be y over 2. Does that seem okay? The next step is take half. Take half of linear term and square it. Add and subtract same side. Okay. This is what I think our United States government does, not with these things, but the United States government says, hey, look how good this is when taken away from over here. Okay? So when people say, oh, our economy is doing so great, but yet unemployment's still high, you're misdirecting the public. So I'm going to do that here. Okay, I'm going to take half of my linear term. What's my linear term? 4x, thank you. Okay, so I'm going to take half of that. What is half of 4? 2. I'm going to square it. 2 squared is 4. So I'm going to add 4, but I'm also going to subtract 4 from the exact same side. I'm going to add 4 and I'm going to subtract 4 from the exact same side. Okay, the reason I want to do that is I want it to say equal. So if I do one thing to one side and I do the opposite to that same side, it's still going to be balanced. Now I could have said, let's add 4 to the right side and let's add 4 to the left side. Okay, I could have done that. But if I add and subtract 4, that could take place nicely. This is my complete square. If I factor that, what do I get? X plus 2 and x plus 2, which is the same thing as x plus 2 squared. Got to combine these together, so I'm going to make that 8 over 2. So I'm going to get negative 15 over 2. Okay, so again, this is my complete square. When we say let's complete the square, I want to make it a perfect square trinomial. If I factor out that trinomial I just made by completing the square, it becomes the exact same thing repeated. Last step, let's get y all alone. So y divided by 2. How do I undo y divided by 2? Multiply. So I'm going to take all the terms multiply by 2. This is going to cancel here. So y is equal to, I'm not going to worry about distributing this over. And this cancels out nicely. This is now what's called vertex form. It's in the form of vertex. Okay? In order to find the vertex now, is you take your opposite inside, opposite of positive 2 is negative 2, same outside, negative 15. So with that now known, if I graph it, negative 2, negative 15. It's opposite inside, same outside. Okay? So negative 215. How fast is this parabola going to grow? How much? Twice as fast. So for my vertex, I'm going to go right 1, up 2. From the vertex, I'm going to go left 1, up 2. I think a board back, I showed that my y-intercept is 0, negative 7. So 0, negative 7. Here's my parabola. Did I solve where it crosses there or there? Or did I just draw where I thought it went? What do you think? Did I solve where it crosses the x-axis? No. If I wanted to know where it crosses the x-axis, I could set this equal to 0 and solve it. I could have used the quadratic formula on the first thing, or I could have left it just like that. Okay? Here's the toughest thing. Think about it. What can you do with a parabola? There's so many properties of a parabola, and any of these you need me to go back to. You know, you have the quadratic formula. And that tells you where it crosses the x-axis. Does it have to cross the x-axis? No. Okay? Obviously, this one will, because it's going to continue growing in an upward fashion, it will cross the x-axis. So you have the quadratic formula to find the x-axis. You can complete the square to solve for x-axis as well. So now you have two different choices of how you want to do it. So if you complete the square on it, and remember you're going to set it equal to 0 and then do everything that way. You can use negative b over 2a and plug in as long as it's in standard form. Okay? Other things you can do is you can put standard form into vertex form by completing the square. They use the letters H and K to denote the vertex. My question out to you is, how do you know which one to use? Sometimes you got to try. Sometimes you just have to take a leap and say, you know what, quadratic, let's go to quadratic formula. Take a leap of faith. We might go and complete the square, and that might tell us some information. Use negative b over 2a to find the x component of the vertex. Plug that back in to find the y components of the vertex. What's the right way to go? I can't tell you. And I can't put a rule up in front of you saying, if it looks like this, then use this. And that's what kind of stinks about this, because there's not an exact location for you to do it. Other things to know is 0, c is where it crosses the y-axis here. This does not, at 0, k, cross the y-axis. Why not? This is not set up in standard form. Standard form works this way. What's your best way you want to do it? I don't know. Can these look different? Can I graph something that looks like this. Can I graph that? Is it a parabola? Do we know where it crosses the x and the y-axis? Yeah. Okay. What is my a value up here? What's my a value? 3. What's my b value? 0. It's not there. What's my c value? 0. If I went and said, what's negative b over 2a? Well, negative b over 2a is this. What's negative 0 over 6? 0. If I plug 0 back into this, what do I get as a result out? Where does it cross the y-axis? 0, 0. Okay? How does this one graph? I have my vertex as a graph. Right one up 3, left one up 3. This kisses the x-axis one time. Means it has one solution. This one particular solution is 0. Okay? So sometimes you're not going to have your b and c value. Sometimes you might have this. What's my c value? 0. What's my vertex? You're going to get negative b over 2a. Plug in. So that's going to give me negative 5 over 2 times 2. So I'm going to get 5 over 4. Plug that back in to get your y component out for your vertex. How fast would this one grow? Right one, left one from your vertex, up how many? 2. Okay? Is it possible you have a problem that you don't have a b value on? What's negative b over 2a? Where's this vertex going to exist? 0, 10. 0, 10 is like here. Opens up. Right one up 3. Left one up 3. Does this one ever cross the x-axis? No. If I use the quadratic formula on this, where would I have a negative? Under the radical? All right, I got a worksheet packet for you that we can work on. It's an unbelievable amount of problems. 1, 2, 3. All right, so why don't we do this? Let's find, we got what, 7 minutes? Let's get these out. As soon as you get it, start looking through. Let's find some problems that we can work on that I can go through and help you on. Right away after the board. Well, we'll see how far we get. All right, take a look. Where should we start? Which one should I start on? Any of them. Give me a little bit more than that. I will say that 1 and 2 are pretty easy. 3 and 4 are already in vertex form. 24? All right. 22? Okay. Number 22, f at x is equal to 3x squared plus 12x plus 4. Okay? Let's answer the questions that they have. I'm not going to answer on the vertex yet, but I know the y-intercept. What's the y-intercept? 0 what? 0, 4. Is that okay so far? They want us to find the x-intercept. So we can do that a couple of ways. They want us to find the vertex. We can do that a couple of ways. Does the negative b over 2a look like it would be a good way to get the vertex on this one? I think so. It's set up in standard form, so let's start finding the vertex here. So I have negative b over 2a, comma, plug in, right? Because it's set up in standard form, this might be a good thing to start. So I have negative b. B is 12 over 2a. A happens to be 3, so I'm going to get, what is that, negative 12 over 6, which is negative 2. So the x component of my vertex is negative 2. How do I find the y component of the vertex? Plug it back in. So taking this, I'm going to plug negative 2 here, negative 2 here. So I have 3 times negative 2 quantity squared plus 12 times negative 2 plus 4. Okay, what's negative 2 squared? 4. 4 times 3, 12. 12 times negative 2, negative 24 plus 4. Okay, let's see. 12 minus 24 is negative 12. Negative 12 added to 4 is negative 8. I have my vertex. Do I have enough information to solve where it crosses the x-axis? I could. What formula is going to work best? Quadratic? X is equal to negative b plus or minus square root b squared minus 4ac all over 2a. You agree with that? Did I put it up right? Let's do the arithmetic. Negative 12 is hanging out as is for right now. 12 squared is 144. Negative 4 times 3 is negative 12. Negative 12 times 4 is how much? Negative 12 times 4 is how much? Negative 48. All over 6. What's 144 minus 48? How much? 144 minus 48? 96? Okay. Check to see if we can write 96 down. Does any perfect squares go into 96? There might be with some left over. So 96 is going to break down to 4 does. Is there any other squares to 16? Someone go 96 divided by 16, see if that works. 6? Sweet. So 96 is the same as 16 times 6. Is that what you said? So what's the square root of 16? 4. So negative 12 plus or minus 4 root 6 over 6. Reduce the fraction. So 2 goes in here, 2 goes in here, 2 goes in here. So this is where it's going to cross the x-axis. So negative 12 plus 2 root 6 divided by 3, and negative 12 minus 2 root 6 over 3 is where it crosses the x-axis. Do we really know where this crosses the x-axis? Yeah.
Would it be negative 6 plus or minus?
Yep. Thank you. I reduced it and forgot to bring it down. Thank you. So negative 6 plus 2 root 6 over 3, and negative 6 minus 2 root 6 over 3 are the 2 places across the x-axis. Do you know graphically where that's at? No. I know exactly where it's at numerically, but I don't know graphically. So if we were to graph this, vertex is at negative 2, 8. So negative 2, was that negative 2, negative 8? I'm sorry. Negative 2. Oh, finish this packet, or let's do this. Have you guys do the evens. Do the evens on this packet. Sound like a deal? Remind me that I assigned that way.